So in this problem, we are given a triangle ABC, and using the law of sines, we need to show that the ratios are equal to each other. So let us begin. So first, what we'll do, let's consider a triangle ABC. For simplicity, we are considering an acute angle triangle. We can also use an obtuse angle or a right angle triangle, but the result will be the same. So if we consider the triangle ABC and the side, let's consider the side opposite to A, which is represented by BC. We're going to represented by the letter A in lowercase. For the side opposite to angle B, we're going to consider the letter B in lowercase, and for side AB, which is opposite to angle C, we'll be representing it with letter C. So here, the law of sines, let's write down the law of sines. The law of sines, it states that if we take the ratio of the side A to that of sine of the angle opposite to it, so that's sine A, this ratio will be equals to the ratio of side B to that of sine of the angle opposite to it, so that's B, and this will be also equals to the ratio of side C to that of sine of the angle opposite to it, so that's sine C. Because this is defined as the law of sine. Now what we're going to do in this law of sine, we'll consider all these three ratios are equals to some constant lambda. In doing so, now we can represent A as lambda times sine A. Then B will be represented as lambda times sine B, and C will be equals to lambda times sine C. So let's start with one of the ratio. We'll begin with A times sine B minus C whole divided by B squared minus C squared. We'll replacing the value of A, B and C with the respective values. So A will then become lambda times sine A multiplied to sine B minus C whole divided by B squared minus C squared. So B squared will be lambda squared multiplied to sine squared B minus C squared will give us lambda squared times sine squared C. Now, in the numerator, we have sine A. Here we're going to use a fact. We know that in any triangle A, B and C, the sum of the interior angles A plus B plus C adds up to pi radians. So that means A can be also represented as pi minus of B plus C. And if we take the sine of the angles on both sides, so sine A will become equals to sine of pi minus B plus C. Then what's the value of sine pi minus B plus C? So that's simply sine of B plus C. So that means sine A is equivalent to sine B plus C. We can replace this in the numerator. We will get lambda times, we have sine. Instead of A, we're going to get sine B plus C multiplied to sine B minus C whole divided by, so if we take lambda squared as the common factor in the denominator, we have lambda squared multiplied to sine squared B minus sine squared C. Now luckily, sine B plus C times sine B minus C in the numerator, that's actually the expansion of sine squared B minus sine squared C whole divided by lambda squared multiplied to sine squared B minus sine squared C. So we have a common factor in the numerator and the denominator. The lambda, one lambda from the numerator, one from the denominator also cancels out, and that finally leaves us with 1 over lambda. Similarly, if we consider the next ratio, B sine C minus A, let's take B times sine C minus A whole divided by C squared minus A squared. So we can replace the value of B with lambda times sine B. We're going to get lambda times sine B multiplied to sine of C minus A whole divided by, so we have C squared. So C squared will be lambda squared times sine squared C minus A squared. So that will become lambda squared times sine squared A, which will be equals to lambda times. Now what we can do, using the same idea that A plus B plus C equals to pi, so we can show that sine B will be equals to sine C plus A. So we can replace this value into numerator. So we have lambda times, so sine B will become sine C plus A. So that's multiplied to sine C minus A. Now in the denominator, we have a lambda squared as the common factor. So that's multiplied to sine squared C minus sine squared A. Now sine squared C minus sine squared A, that is simply sine C plus A multiplied to sine C minus A. So that means we can factor out sine C plus A from the numerator and the denominator, and 1 lambda from the numerator and the denominator, leaving us with 1 over lambda. Similarly, we can also show that C multiplied to sine of a minus b whole divided by a squared minus b squared. So this ratio will be also equivalent to 1 over lambda. So therefore, we can say that if in a triangle ABC using the law of sine, we can say that these three ratios are equal to each other.